Okay, welcome MCT4C folks, day 70. We're really on the home stretch now, actually. Uh, Today, we're investigating properties of circles. Yesterday, we sort of spent a bunch of time talking about the bits and pieces of circles and giving them names, and we're practicing that in the 3-minute review today. In the diagram, state or calculate any major arc. Remember, a major arc is kind of around the outside. So there's a minor one. The long way home would be the major one, right? So I could say, something like ACB, arc ACB, and then it would be understood that we were going around the outside, the long way home. A tangent is a line that touches only in one spot. This one here would be a secant because it cuts in two spots. EF is a tangent. A chord is any line segment that connects two points on the outside of a circle, so CF is a chord. The length of minor arc AB. See, now we're talking. Now we got something to do. There's minor arc AB, and we want to find the length of it. Well, arc AB, the way we did this is we kind of figured out whatever fraction that the angle is, the central angle, and it's 70 over 360, that's going to be the fraction that the arc is of the circumference, right? So it's that fraction of the circumference. That's just the circumference, and then we can finish it off. D was, there's 5 inches there, so this D would be 10 inches. Bash that into a calculator, and it's about 6.1 centimeters. About. Okay? E is more interesting. The measure of obtuse central angle AOC. So this angle here, AOC, that's what we want to find in E. If the shaded area, so this blue section is 10 pi square inches. 10 pi square inches. Well, how do we do that? Well, I mean, this is backwards. We're given the area, right? Well, we know that the area of the sector compared to the entire area, which is just pi r squared, r is 5, so I could fill that in, and I'm going to in a second, is the same as the fraction of the circle that I've got. Well, the fraction of the circle is angle AOC. It's an obtuse angle, I hope anyway, when I calculate it, over 360 degrees. This angle to all the way around is the same as this area to the entire circle, right? Well, now we're flying here because we got pi's that cancel out. That's why they gave us the area as having a pi in it. And the radius was 5 squared. And now we're off to the races, right? Cross multiply because it's this thing that I want to solve for. So I got 10 times 360 divided by 5 squared, 25, and that's angle AOC. And hopefully this makes sense. It looks like it's an obtuse angle. It should be an obtuse angle, and it is 144 degrees. Nice. That's the 3-minute review. And what's nice about today compared to the long lesson yesterday and the lots of homework is today you kind of get to fiddle around with the computers a bit. So let's have a look at what we're doing. This is the lesson. This is what your note looks like, and it says to get a computer, open the PDF of this file so you can click on the links. Now let me do that. I gotta open the PDF file. It should be easy for you. It'll be right next to this video. Okay, so I've opened my PDF version of this, and I should be able to click on these links, and that'll take you to some some website. It'll take you to a website, and you might get a few weird messages, because what this is doing is it's running, this is Geogebra. This is Geogebra loading, and it's working, and essentially there's some instructions. Let me see if I can split screen this baby here. there's some instructions for you to follow. There's the instructions for you to follow. You do that, and there might be some instructions in here for you to follow, and then you find some stuff out about circles. It sounds like fun, doesn't it? And it is. It's going to be great. Lots and lots of rules. I think there's, what, about 8 investigations, all on the internet, all interactive stuff. You can move. You're going to be able to move points around. Let me see if I can do that, actually. Move points around. And see this and what's going on. I don't know what's going on here, but let's show the chords. OP and OQ are equal, so now if I start moving points around, what happens? The chords are moving, I guess. What happens if I move this point around? And I play around with stuff. What else can I? Aha, there I can move some stuff around. I'm moving stuff around, and I'm observing things. Okay? And there is some conclusion. There's some sort of thing that you're supposed to get out of these investigations. I'm not going to say any more. I don't want to spoil it. It's going to be awesome doing these investigations. So we'll stop. I'm going to stop there. And there's several of these. You just fill in the blanks. That's the lesson for today, is for you to do that. The one thing that I want to mention at the end is Geogebra. Okay? Darn. And we've used Geogebra before. Remember, that's the kind of symbol for it. You get it going, and you do have to be patient with Geogebra once you get going. It does take a long time to load on our computers, even on my computer, as we can see. And on this one, what this is supposed to do is you're going to actually build the investigation yourself. All those other ones, other people built, but we want to build this investigation ourselves. And essentially, all I want to say, you're gonna follow these instructions, and you're gonna get a little bit lost, and you'll fix it, and you'll learn. You'll learn. What I want to mention is just when you hover over with your mouse over something, that it'll tell you what it's about. So there's the perpendicular line tool, and line through 2-point tools, new point tools, and notice that the line through, this is creating lines. If I click on the little arrow, I can see a whole bunch of different ways to make lines. So you're going to have to play around with some of these and experiment on what the right tool is. It tells you in the instructions, but you will have to be a little bit patient. So have fun with that, playing around with the computers, and look at that. Only one part to this video, and it's not even 10 minutes. So thanks for stopping by.